Sir, my file is visible to you?
Yes, it is visible. Maybe you can just press the Control L in the presentation mode and then start presenting.
Sir, I am doing similar, but it's showing leave the event. So I can't able to make it full screen.
Okay, then maybe you can present like this only. Please start the presentation.
Okay, sir. First of all, I like to say thank you on behalf of my co-authors. I am presenting this work on DPANN. 1 minute, sir. Actually, this is not working fine. Okay. Very good morning, sir. Sir, I am Indijit Kumar Sinha from IIIT Allahabad. I am research scholar there. This is my overview for the presentation. I will start with my motivation and I will move through introduction part, experimental setup, methodology, experimental results, and I will conclude with my conclusive statement. I got idea for doing this work from this motivation. In recent time, we have seen that intense use of internet is going, which leads in sharing a lot of information among the people. This information may be a public or personal. Personal, we can say that the information having some sensitive information that cannot be given to public domain. So the information is protected by every individual. We also know that different learning models desired for a lot of information which helps in improving their efficiency. Lately, it is claimed that learning models may be compromised by adversaries. This is because their different attacking models are performed on machine learning algorithms like membership inference attack, membership uh, model inversion attacks. These all attacks shown that a certain information can be breached through machine learning models. This motivation gives us to use private learning models on private information. As we know that machine learning models are designed to predict the value and classify the instance based on the data set. As earlier I said that data may be personal or public, but their state should be maybe different. Like a data can be a picture, videos, live locations, and health records. These data have their different aspects, and these can be utilized by machine learning models in different ways, like the disease diagnosis model or medical analysis model. In the area of health sector, we can use these models are used to get relationships and correlations within the data, which leads to memorizing sensitive information of individual data during training of machine learning models. While these models are open for others use, like diagnosis model in which all doctors use all over the world. This uh, issue for privacy consequently makes health related data not to be used uh, in an efficient manner. For making this fully utilized uh, information, we introduced differential privacy in machine learning. As earlier I said, different have been happened on machine learning models. These different attacks is shown in cited paper 15, which shows how attacks are performed and what the consequences can be happened. An adversary might be able to look over the published model and learn the private information about any individual. These all kind of reason this is because and different attacks can be performed on machine learning. So we are using differential private notion in our machine learning models to make our model private. Differential privacy is applied to make privacy preserving machine learning models. Privacy comes with a cost of downfall in efficiency of machine learning model. It means when we apply differential privacy, there we will get a certain decrease in efficiency of machine learning models. It can be because it is because of noise added at different stages of machine learning, which makes it understand in different way for every situation and makes certain difference from the original model. But at the same time, it makes our machine learning models more secure than previous one, and this utility and privacy trade-off is very major challenge for differential private machine learning models. Here we can see in this picture what happens when we apply differential privacy in machine learning models. We can see that in first randomized algorithm, and answers given to every query, answer 1 to answer n is similar in other randomized algorithm with a similar dataset having one entity difference. Means only one individual data are interchanged or removed from data set so that their answer should be nearly same. In first point, we can see that several papers have mentioned how to predict the growth of disease using machine learning models. These papers helped me for making this work in fruitful manner. In paper 117 and 24, we got idea about how to make a differential private stochastic gradient descent. In this, one of the author Kamalika Chaudhary have mentioned how to make a stochastic gradient descent differential private. Few other works like in papers 10 and 14, they have showed that how to make learning models private at giving noise at loss function and adding weights at adding noise at weight also mentioned here. In literature review, we observed that still we have very few works have been done till now on machine learning for privacy concern. So we proposed, after looking all of these things, we proposed this work, differential private neural network on COVID-19 dataset, so that we can predict how much spread of this disease can be occurred during certain time of period, and what is the peak number of cases in India during this period. In our experiment, we have used dataset from Kaggle community, that is COVID-19 in India. We have cited this in our references. From the references, we have consolidated the statewide data to a single country-wise. Means in our data set, we having the data from every state that would be given in daily basis. All data in single point like country-wide data. For optimization purpose, we have used our hyperparameters as 0.01 as learning rate, and we performed 850 epochs for training model. Since there are many external agencies are also affecting the rate of pandemic. So we have ignored all these dependencies. These dependencies are like population of a country, lockdown, how performed testing count, healthcare infrastructures, and its sector. First we will talk about basic NN model. In this, we have only one hidden layer, which is having 32 nodes and one node at output layer. Here, loss function is used is mean square error. In here, we can see that it is stated like 1 by n into summation of y minus y predicted whole square. It means we will see every point of day by what the model is predicted and what the actual data is in our training, and we will find this difference and square this, and this will help in minimizing the our model error. Here n is the number of days in which we are predicting. It means for how much day we are predicting for 50 or 60 or 70. We predicted here 250 days. So we have taken n as 250. We used soft plus as activation function, that is stated as log of 1 plus e to power x. Differential privacy can be introduced in a model at different level, like in input at machine learning itself. Here we applied only in model, so we talk about only this type of differential privacy. We used first model as differential privacy at loss function, second as activation function, and in third we have added noise at weight. These three differential private model have been derived from our basic model of NN. The intuition is to share learned parameters with everyone for their utility purpose while keeping the data safe at original source. We used Laplace distribution as noise to randomize the algorithm. The probability density for the Laplace distribution is given by 1 by 2b into exponential of minus mu minus b upon b. Here mu is mean and b is the local or diversity for the given distribution, where we have set having the mu equal to 0 and b equal to 0.01 as default value in each or every model. Further, we have used noise generated using Laplace distribution is added in loss function. As earlier I have said, this is our first model, and this model can be able to capture the non-linear curve pattern of cumulative cases of COVID-19 without leaking any extra information. Here, what we have did, we added a loss value to every mean squared error function at every point of evaluation. So our model becomes differential private. In other second model, we use this method at activation function, but we make loss function as any over the use it anywhere till this is our novel work. Updated function is here. As I said, the function is soft plus. In our third model, we have added our noise at weights. In this model, we make sure that loss function and activation function would be same as base NN model, and updated weight is addition of some noise which can be from Laplace, and this is our updated weight. These all models are differentially private, makes our basic model in protected manner. Implemented line artificial network have three different DPNN that I have mentioned earlier. It can be seen that adding Laplace noise to loss function gives slower conversion. In this, that first left top corner image having very slow convergence. It means it taking time to train our model in respect of all three methods. So noise added at loss function is slowest among all. Now, experimental results about daily new cases, we can see a minor difference. A major difference. This could be a Laplace. Here we can see that Laplace noise added at three loss function. Three models have shown differently at weight, and noise added at weight have just above the baseline model, and noise added at activation function have the highest peak, and noise added at loss function is intermediate between noise added at weight and activation function, and noise without noise, our base model having the least daily new cases peak. So here this is the scenario of how model describes our data. Prediction for private model 2 is slightly higher by the value of base model, as earlier I have mentioned, and model 1 and 3 are slightly lower to base model in total case counting. So in this image we can see that the activation function having the highest total cases, and noise added at loss function having the least total cases at the last. So we can find the differences in marginal while having better privacy guarantees over the base model. As we increase our privacy budget epsilon, our privacy preserving model will show more differences in prediction. However, this will make our predicting model more private. To maintain this trade-off between privacy and utility, we need to select a privacy budget accordingly. At last, I said that the data private model are being used in different perspective, because health data are very sensitive to every individual. So these differential private models can be used as basic models, and you can use in further aspects. In conclusion, we have proposed this model to achieve the privacy of individual data with maintaining the utility and learning of machine learning model closer to the base model. The advantage of doing this work is to make health sector maintaining individual privacy but as said recently earlier, this model, the model with activation function performs in best manner, while model in loss function noise at loss function performs very weak among the three differential private NN model. The weights of the train model can be shared in instead of the data, so that our data should remain private, while we can utilize this information in global domain. In future, we will work on minimizing this gap between utility and privacy, so that we can achieve a better and efficient model. And I would like to work in the application of federal models of machine learning, so that keeping the local information in more utilized way. So this is my whole presentation. I would like to thank and sir, any questions?
Okay, so now I request all the participants to ask their queries if they have. Okay, so it seems there is no questions from the audience side. Sundrit, I have a question for you, a very quick question. So,
Yes, sir.
the question is, what motivate you to add noise in the whole process? What is the
Sir,
motivating factor for you?
yes, sir. Actually, in 2006, Cynthia Dork have given a novel mechanism for this differential privacy. In this mechanism, they stated how a linkage data means any background information about any data to a particular extent of level. Means we use this noise to randomize the possibilities of getting a answer to be in certain manner. Means if we can take an example of tossing a coin, we have a probability of getting a head and tail is 50% and 50%. But when a uh, biased, we got a biased coin, then its probability would be modified to certain level. It may be 80-20 or 20-80, but who have biased it, then he knows well what would be the most probable answer to it. In that scenario, what similar case, when machine learning models learn to training data, and a adversary performs attack on using similar type of data, adversary knows finds the confidence score, and he gets the identification of any individual who is available in training data, and so in that manner they can breach the individual information. To avoid such kind of information, we add noise to make our algorithm more randomized, to perform more randomized way. Means giving a particular answer to query probability near to 50-50, means we decrease the probability of getting any occurrence to 50%.
Okay, okay,
Sir,
okay. Okay, so thank you, Indrajit, for presenting this work. Thank you.
thank you, sir.
Okay. So now I will invite the presenter for the paper spread and peak prediction of COVID-19 using ANN regression. In the attendee list, I think mostly all the authors are there. So who is going to present this paper?
Hello,
Okay,
good afternoon,
all the
everyone.
authors. Yeah, Anupam, you are going to present this paper?
Yes, I am going to present.
Okay. So please start presenting the paper 119, which is the spread and peak prediction of COVID-19 using ANN and regression. So
Okay,
Anupam, you have 20 minutes for the presentation and then 3 minutes for the question answer session.
sure.
Yeah, please adhere to the timings.
So, is my screen visible?
Yeah, it is visible.
Okay, so good afternoon, everyone. So the title of my paper is our paper is Spread and Peak Prediction of COVID-19 and Regression, and we completed it in the Machine Learning and Optimization Lab of Indian Institute of Information Technology, Allahabad. I am Anupam Prakash, and my co-authors are Piyush Sharma, Indrajit Kumar Sinha, and Upendra Pratap Singh. So, as we know that coronavirus disease is an infectious disease which is caused by severe acute respiratory syndrome, coronavirus 2, and it has taken the world by a huge shock. It was officially announced for the first time on 11th of February 2020, and since then it has taken a toll on physical as well as mental health of a lot of patients. The symptoms vary from a fever, cold, sore throat, loss of taste. And there are also a lot of people dying because of this virus. And so it has affected the country in many countries in catastrophic ways, because many of the countries were pushed to lockdown, and which forced many people to unemployment. It has impacted the economy, the transportation, the livelihood of the people as well, because and also it has led to food scarcity, because the government has to offer free food supplies for everyone, and a lot of people lost their job. So I think it was important to predict the effect of virus in coming few days, so it would help the government to plan accordingly. So amid this turmoil, the most common question that was crossing everyone's mind is that what will be the statistic about infection? What will be the peak? When we will reach the peak? How many patients will be affected by then? What will be the death percentage? And also, these predictions were important for the government and the medical staffs to plan what actions are required to be taken, like till when the lockdown has to be extended, when will the shops should open, when will the transport should open, how many beds are required at what time. So in this paper, we have tried to model the infection statistics, and the novelty of this paper is that we have tried to use as simple model as possible without compromising on the accuracy results. So we did the literature survey and found very complex models, but they didn't achieve a great results either. Also, we have proposed a new metric called the growth ratio for modeling active cases, and we have used this growth ratio metric to use for peak prediction. So about the data set, so the COVID-19 data set for India is taken from the official website of Government of India, Ministry of Health and Family Welfare. It has been web scraped from it, and it begins from the data begins from January 30, 2020, when the first case was seen in India. And similarly for other countries like USA, Italy, and Spain, the data begins from the day when the first case was seen on in these countries, like January 22 for USA, January 31 for Italy, February 1 for Spain, and these data is taken from GitHub. The end date for all the data is June 6. That is when we completed our paper. So we divided the dataset for India into three categories: the top five affected states, the moderately five affected states, and the least five affected states. We did this on an assumption that the curve for top five affected states will be different from the rest of the country, because the uh, rate of spread of virus will be proportional to the active cases that are present in those states. So if the number of cases are high, then obviously the growth will be exponential as compared to the least 5 affected states, and that is why we have made this division. Now, coming to the proposed methodology, we tried to use three approaches. The first approach, we tried to model the confirmed cases. And we began modeling the confirmed cases with linear regression by using XY pair, where X was the number of days since saw the first case, and Y was the total number of confirmed cases. We moved from linear regression to polynomial regression with varying degrees like 4, 5, 6 that suited the curve the best. And then we also moved to ANN where 3 hidden layers of 30 neurons each were used. Then the second approach that we tried to use was modeling the active cases. So we know that the total confirmed cases is an ever increasing function. It will always increase, but active cases is something that will go down because it is actually total confirmed cases minus total recovered cases and total death. So when patients will recover, active cases is likely to go down. So if we model the active cases, we can actually try to find out when will active cases turn to zero. To model these active cases, we have used polynomial regression. And the last is the peak prediction model, for which we have used a new metric, the growth ratio. We define the growth ratio as the number of active cases on day I divided by the number of active cases on day I minus 1. And we have modeled this growth ratio and predicted the future values of growth ratio. And based on these future values of growth ratio, we have tried to model the active cases in the coming days. So these are the results that we obtain. As we said, we begin with linear regression. And on y-axis, you can see the number of confirmed cases. On x-axis, there are number of days. On left side of the graph is in log scale, while on right side, it is in linear scale. We have also, we tried to model in log scale because in log scale, the curve appeared to be more closely linear. And so the regression was could be fitted easily, and then we transform that curve to exponential value to suit the linear scale. So on left side, the graph is for top 5 Indian states, and on the right side, it is for the moderately 5 Indian states, affected states. And now this graph is on the left side is for bottom 5 Indian states, and on the right side, Spain. So we can see that the linear regression model is not fitting the curve quite accurately. So we moved on to polynomial regression. So these were the results obtained for polynomial regression. On left side, we can see the results for top 5 Indian states, and on the right side for top 5 moderately affected Indian states. We can see that the curve has fitted the actual cases better than the linear regression, where blue indicates the predicted cases, whereas red indicated the actual cases. Again, the left hand side is a logarithmic scale, while right hand side is linear scale. And these are the curves for Spain. So the problem with Spain is that the peak has occurred by then, and there was a point of inflection, and the polynomial regression was missing that, and that is why we moved on to artificial neural network. So this is the modeling of the cases by artificial neural network. And again, red indicates the actual cases, while blue indicates the predicted cases. On left side, we can see top 5 Indian states, and on right side, we can see moderately 5 Indian states. And these are for bottom 5 Indian states. And now on the right side, you can see for Spain. So again, we can see that for Spain, the results are much better than regression models. And these are the results for USA and Italy by ANN. And then we tried to compare it using the accurate the total number of predicted values for the date June 6. So the actual cases are for top 5, middle 5, and bottom 5 Indian states are indicated as compared to the predicted cases by ANN. After then we try to model the active cases so that we can predict when the active cases can go down. And these are the results that we obtained for Italy and USA. We tried to model this with ANN, but ANN was overfitting the curve and it was not converging. For like, if we talk about Italy, then the peak has already occurred by then, so it could converge. But for countries like USA, in which the cases were still increasing by then, ANN was not converging. So we kept going with polynomial regression. And then these are the results obtained by Spain, and these are on the right side, there is by moderately affected states of India. Then we move to growth ratio, and the growth ratio, as we described earlier, was the metric used to model the active cases. And once we fitted the curve with the growth ratio, we use it to measure the future growth ratio, and we predicted that the peak will occur when the growth ratio will hit 0. So these are the results obtained for Spain, and these are the results obtained for USA. On the left side, we can see growth ratio, and on the right side, we can see when the same curve is extended for the future. And these are the growth ratio model of Italy. And now these are for the bottom 5 Indian states. There were variation in these places, like the bottom 5 Indian states and the moderately 5 Indian states were quite huge in growth ratio, because the cases are still increasing were still increasing in these places. The new cases were coming and people were getting recovered. So the spread was not uniform, and that is why there is so much variation in the growth ratio, as we can see in black. And this is the result for the top 5 Indian growth ratio. And on right hand side, when the curve will hit 0. So in conclusion, we have tried to build a prediction model to analyze the global spread of pandemic in India as well worldwide scenario. We tried to use simple model like regression and ANN to avoid the unnecessary computations. And we have also used the growth ratio metric to use the peak prediction. Uh, for future, we are looking to model this as the time series data, and same analysis can be done using models like LSTMs. So these are the few of the papers we referred, and that's it from my side. Thank you, and I am ready to take any questions.
Okay, okay. Now I request audience to ask the queries if they have any. So any query from the audience side? Okay, so in case of no query, so Anupam, I have a query for you.
Yes.
Yeah. What about the data which you have used actually in the whole process? How authentic the data is? Because all the prediction is actually working on the accuracy of the data. If your base data or the training data is not accurate, then you may not able to get the desired accuracy in the particular process. So how can you rate your data which you have used for the training purpose?
Well, I totally agree that the data is very important in this model, because we are using historical data, and that's why we have tried to use the official figures given by the countries and the government of those respective countries. So that is why we took the data for India from the official website of Government of India. We have scrapped it from there. So we have tried to use the official data rather than some any of the random websites that are producing data. So we expected that the official data will be accurate. That's the assumption that we made.
Okay, so I think in your experiment you have not done any experiment on the death rate. Why so? You are just predicting the infected persons, but not the total deaths in a particular country. Isn't?
Actually, our aim was to model the prediction of the when the peak will occur and when will the pandemic is likely to end. So we try to model active cases and when will the active cases likely to go down to 0, and when will the active cases will be maximum. So yes, that is very important, and we could have done that, but our aim was basically to because active cases is something that determines how the pandemic is going to span out, because the number of people will be affected by the people who are active, who are actively having corona, and all the decisions that are needed to be taken, like till when the lockdown has to be extended or when we have to open, that is based on active cases. So yeah, that is what we focused on. That's where our focus was on.
Okay. Okay. So how accurate your predictions were? So let's say you just take a future date and then try to find out the prediction from your model, and if you look at the official data for that particular date, so how accurate your prediction is? Because I didn't see any accuracy in the experimentation part.
Yeah, so we tried to model it by graphically. So we tried to keep it like the graph. We can see that actual cases is represented in red and predicted cases is represented in blue. So accuracy was like around 85% on an average if we talk about the confirmed cases. However, if we are talking about active cases, so we know that after June 1, the lockdown in India was lifted, and that affected the modeling. And so if you talk about the next few days, like next 10 days, next 15 days, then this model gives quite a good result. But if you're talking about 1 month or 2 months later, because there are so much of variables involved, like the factors of lockdown or the new treatment policies coming up, new medicine, new strategies for treatment is coming up, and that was a little difficult to model. But yeah, for if you're talking about 10-15 days, the accuracy was around 85% on an average, 80-85%.
Okay, so Anupam, my last question is when the pandemic is going to end as per your model?
So actually, the data that we collected was till June 6th. So uh, uh, it predicted around 210 days for 200 around 200 days for every country. So that was around late July and early August, based on the data that we collected.
Okay, so whatever the data you have on the basis of that, this 200 days decision was there from your model.
Yeah, right.
Okay. Okay. Thank you, Anupam. Thank you for the nice presentation. Thanks a lot.
Thanks a lot. Thank you.
So now I request the presenter of the paper 59, the RDWT SVD Firefly based dual watermarking technique for medical images to present the work. Hello. Yeah, Ashima, can you please put your presentation in the presentation mode and then start? Yeah, please. Ashima, I think we are not getting your voice.
Is it, yes, sir. Is it still not audible? Hello?
I think there is some issues with your mic or something.
Audible?
Still your voice is not coming.
Hello.
Yeah, now I think it is coming. And I request you to speak little louder.
Yes, sir. Yes, sir. Sure.
Sure. Okay.
So this is the outline of my presentation. This is the content I will be discussing today. So starting with the motivation, there has been a rapid increase in the internet usage and the amount of data being shared over the internet in the recent years. This has made digitization possible in the medical field as well. Better study of symptoms, better treatment of patients is now possible. However, it has resulted with a compromise in the security and privacy of the medical records. DICOM, Digital Imaging and Communication in Medicine. It is a standard used by various organizations to communicate the medical data. It has a header attached with a file which contains the significant information about the patient. Maintaining the privacy of these headers during the transmission and storage is another big issue of concern. According to a survey conducted in 2017, it was concluded that medical-related identity theft 27% of the total identity theft. Information affects the life of an individual to a very great extent. Today, the world is suffering from coronavirus, which has been declared as a global pandemic by World Health Organization. During these times, a lot of information about the patient is being stored in the servers of the hospital. This information provides a reference to the various healthcare professionals to develop the future plans. However, it has led to the risk of data security and privacy. So there is a need for a strong mechanism which can help in maintaining the security and the privacy of these confidential patient records. Watermarking helps in resolving all such issues. It is basically a process of embedding the confidential information into the multimedia objects in such a way that the watermark can be extracted later by only the authorized party. It is also helpful for resolving any ownership issue that may arise. Since the watermark is embedded within a cover media, so the amount of bandwidth required to transmit the whole information, it reduces. And for the same reason, the amount of storage space required, it also reduces. Watermarks helps in maintaining the confidentiality of the data and also helps in protecting the data against any kind of tampering. This is the basic framework of any watermarking technique. There are basically two processes. The first one is the embedding procedure and the second one is the extraction procedure. In the embedding procedure, the watermark is embedded into the cover media using a secret key and an embedding algorithm, which produces a watermarked image. Watermark media. This watermark media is then transmitted over to the receiver through an open network. At the receiver end, the received media is, along with the secret key, is passed through the extraction algorithm and we get the watermark back. So these are the basic characteristics of any watermarking technique. The hidden watermark should withstand any kind of attack that may occur. The watermark should only be detectable by the authorized party. Imperceptibility is basically the measure of similarity between the original cover and the watermark cover media. Embedding capacity is the amount of data that can be hidden within the cover media while maintaining a good amount of imperceptibility. Security, we need to maintain a high amount of security in any watermarking technique while having low computational complexity. The other main characteristics of any watermarking technique are the false positive rate, key restrictions, and the tamper resistance. It should provide tamper resistance by maintaining the authenticity and integrity of the watermarking system. However, it is very difficult to maintain a balance between all these characteristics in one single watermarking system. So we need to get as optimal results as possible. So watermark, apart from smart healthcare applications, the watermark is currently being used in many other applications. Due to the lack of resources in rural areas, the distance education is widely opted. Watermark helps in authenticating the study material which is transmitted over the network. It is also helpful in securing the e-voting system, which could be helpful at the COVID-19 times. Apart from these applications, it is helpful in providing copyright protection in the military area, digital forensics, chip and hardware protection, and fingerprinting. So moving on to the proposed technique, we have proposed a dual and robust watermarking technique, which helps in securing the digital medical records. Our proposed technique is basically divided into three sections: the watermark generation, the watermark embedding and extraction, and finally the optimization procedure. In the first process, we are generating a watermark. We are achieving dual watermarking by embedding the text watermark within the image watermark using DWT decomposition, which gives us the generated watermark. Before embedding the text, we have applied turbo code, which helps in reducing the bit error rate caused due to the channel noise. This generated watermark is then embedded into the cover media. For this, we have subsampled the cover image, and the entropy of each subsample component is calculated. The subcomponent with the maximum entropy is chosen and is decomposed using RDWT, redundant DWT. Further, on the selected subband, SVD is applied on the scalar, on the achieved singular matrix. The generated watermark is embedded, producing the watermark image. Imperceptibility and robustness are two main basic characteristics of any watermarking technique, as discussed before. So we need to maintain a balance between them. In order, if we try to improve the imperceptibility, the robustness decreases. However, if we try to improve the robustness, the imperceptibility decreases. So scaling factor is one such variable which helps in maintaining an equilibrium between these two characteristics. So in spite of manually selecting the scaling factor, we have used a Firefly Firefly optimization technique, which produces an optimized value, which is used for final embedding and the extraction procedure. Firefly is basically a nature-inspired swarm intelligence optimization technique, which is inspired which is inspired by the flashing light of the fireflies. It basically works on the fact that the less bright fireflies are attracted toward the brighter fireflies, making the brightness of the firefly as the objective function. Moving on to the experimental setup, this is the optimization function we have used in our approach, in which alpha is the balancing factor, which basically helps in maintaining a balance between the PSNR, BER, and NC. PSNR is the peak signal to noise ratio, which gives the measure of the imperceptibility. NC is a normalized coefficient. BER is the bit error rate, which gives the measure of the robustness. Our results, we have simulated the proposed method using MATLAB R2017A version. Since we have achieved dual watermarking, so we have embedded two watermarks. The first one is the patient's report, which is of 24 characters, and an medical image is the second watermark, which is of the size 256 cross 256. These two watermarks are embedded within a medical image, which is of the size 512 cross 512. To authenticate the system, we have tested it. We have tested the proposed method on different medical and non-medical images. We have also tested for different number of iterations of the optimization used, and we have tested the robustness against various signal processing attacks. So This is a sample of the images that we have used. The first one is the original cover image. The second one is a watermark image, followed by the watermarked image, which we obtained after concealing both the watermarks into the cover image. And the fourth one is the text watermark, which we had used in our experiments. So moving on towards the performance and moving on towards the results of our system, the robustness and the imperceptibility of the proposed work is tested against various signal processing attacks. And here are the results. The acceptable NC value is more than 0.7. So it can be illustrated that in all the attacks, acceptable NC value is obtained, except for histogram equalization. Also, BER is 0 for every attack except for histogram equalization and the shafting mask attack. We have obtained a good amount of imperceptibility. So the PSNR is 43.58 decibels. The feasibility of our system is of our proposed work is tested for different medical and non-medical images. And the results are as follows. In the medical images, the histogram equalization is still not standing up to, still not giving the acceptable NC value and the acceptable BER. However, for the cameraman and the cell images, the histogram equalization is giving a good amount of robustness. However, the BER is still not acceptable. For all the other images and for all the other attacks, the acceptable value of NC, that is close to 1, is obtained. And the highest value of PSNR obtained is 47.41 decibels in the case of cell image. We have varied the number of iterations in our optimization technique, which draws us to the conclusion that as we increase the number of iterations, the value of the results, they start approaching the optimal value. It is not the optimal, but they start approaching the optimal value. With the same conclusion that the histogram equalization is not giving acceptable NC and BER value. For the other attacks, the NC value is acceptable. We have also compared our technique with the established state-of-the-art technique, and except for the histogram equalization, our technique has given good amount of robustness in case of BER, since it is less in every other case. Moving on to the NC value, when compared with the same technique, the NC value obtained is much higher than the established state-of-the-art technique. However, in the case of histogram equalization, we fail to achieve better results. So I'm concluding my presentation with few words. We have proposed a robust and secure dual watermarking technique using a hybrid of RDWT, SVD, and firefly optimization. We achieve dual watermark to provide an extra level of security to our technique. The text watermark was encoded using turbo code, which helps in reducing the effect of channel noise using the turbo code. Also, we tried to maintain an equilibrium between the robustness and imperceptibility by implementing the firefly optimization technique. And when we compared our technique with the established state-of-the-art techniques, an improvement of around 157% was achieved, which is a nice result. In future, we can combine more than one meta-heuristic technique and form a hybrid technique, which can further enhance the results. So these are the references we have used. Thank you, and I'm open to any questions now.
Okay, so I request. Okay, so I request all the audience to please ask the queries if they have any. particularly colleagues from the audience side. Okay, so Ashima, I think you have a question.
Yes, sir.
You have not done any kind of computational complexity analysis uh, on your scheme. So any special reason for that? Because whenever you have the optimization in process, then the optimization process will take a lot of time, and it depends on the size of the data you are considering for your experiments. So can you comment anything on the computational complexity of this method?
Sir, in this technique, we basically try to get an optimized balance between the imperceptibility and robustness. Our main focus was on that point. However, we didn't consider the complexity that much because since I mentioned that we cannot achieve all the characteristics in one watermarking technique, we have to compromise on one or the two other characteristics if we are if we are trying to achieve a good imperceptibility. We have to somewhere compromise with the complexity.
Okay. Yes.
I have a question from Ashima.
Yes, ma'am.
Yeah, this is Nidhi Goyal. Ashima, you're talking about watermarking and you have showed results regarding, the imperceptibility and the robustness of watermark. That's all is agreed. But when you're talking of medical images, an important parameter is that the watermark or any information, be it a visual or a textual information, embedded into it should not disturb the medical information, so that the diagnosis of the doctor goes wrong. So have you considered that particular aspect in your paper? Because other than PSNR, I could not find any parameter that, ensures that the medical information before the embedding and after the embedding is intact.
Ma'am, PSNR is one among the very good parameters which helps us in finding the similarity between the original cover and the watermarked cover image. And the acceptable PSNR value is around 27 decibels, and the PSNR value we are obtaining is around 43 decibels. So there is a good amount of a gap between the acceptable and the obtained PSNR value, which is a sign that the watermark image which we are obtaining is not that disturbed.
Yeah, I understand that, but at the same time, when we all are working in, image processing area, we consider PSNR as the basic value. Nowadays, many parameters are coming up. Structure similarity index is coming up. Edge detection is there. So, have you evaluated your, cover image and the watermarked image over those parameters, and what are the results for that?
No, ma'am. It's apart from PSNR, we haven't evaluated for SSIM, but yeah, in future we can do the same.
Okay, I believe in medical we have to be a little considerate about the information. So that was my question. Thank you, Ashima. And one more question, Ashima. What kind of images have you mainly focused on, or is your watermark, generalized for any kind of medical image that is there, and from where you are taking the data?
Ma'am, basically we have taken the data from the medpics. And this is visible on the reference number 9. And ma'am, we have tested our technique on almost on various kind of medical images, including MRI, kidney stone, head CT scan, and X-ray. Apart from the medical images, we have also tested it on the non-medical images. So it is a kind of generalized. It is kind of a technique for generalized medical images. Hello.
I believe they all will be grayscale images.
Yes, ma'am. They are all are grayscale images.
All right. Thank you, Ashima.
Thank you, ma'am.
Okay, thank you, Ashma, for the nice presentation. Thanks a lot. So with this presentation, actually we are about to conclude this first session of the workshop Big Data in Healthcare. We are going to have the very good presentations in this particular session. Two are actually related to the ongoing pandemic of COVID-19, where the predictions and then the private privacy has to be included in the whole process. And the third presentation is with respect to the securing of the medical images. So I will thank all the presenters as well as all the attendees to attend this particular session. With this note, I am going to conclude this particular first session of the Big Data and Healthcare, and I invite you all to attend the second session of the workshop Big Data in Healthcare, which is about to start at 2 o'clock. 2 o'clock today after the lunchtime. So see you there in the second session of the workshop. Thank you very much. Thank you for your presence.
Thank you, sir.
Okay, thank you.
No, sir, there's nothing that you have to do. I just have to like finish the recording and then I'll have to upload that. So if you want, sir, you can leave.
Okay, thank you.
Thank you.